Welcome back, ladies and gentlemen. Today we're starting our new unit and we're going to continue working with linear equations. It's just now instead of working with one linear equation, we're going to be working with two linear equations. And those two sets of linear equations are called systems of equations. So we're going to look today at solving systems of equations by graphing. There's three different ways we're going to learn to solve a system of equations, and it depends on how that equation is written, really determines how I solve that system of equations. But we're going to start with graphing the systems of equations to find a solution for both of those linear equations. So, what is a system of linear equations? I've already said, it is where you have a set of two or more linear equations. I have these ones both written in slope-intercept form just because that's the most common and easy one to begin working with. But a solution to these is going to be an ordered pair that's on a graph. So each of these equations have a line on the graph, and those equations on the graph are going to intersect somewhere. So that point that they intersect is going to be a solution that solves both of those equations. So we're going to look for where those linear equations intersect, and that intersection is going to be where our answer is, or our solution is, to that system. So how do we solve linear equations or a system of equations by graphing? Well, first, if they are both in slope-intercept form, it makes it really easy to graph each of them. Because you graph them using the y-intercept and the slope. It's easy to graph those lines. So our first step is to graph each linear equation on the same graph. Then you're going to find the point where those two lines intersect. And that point of intersection is that solution to the system of equations. So let's take a look at an example. So we have two equations up here. Y equals 2x minus 2. Y equals negative half x plus 3. We're going to graph each of those equations. So let me start with the first one. Y equals 2x minus 2. If we remember from last unit, this negative 2 at the end represents our y-intercept. Our y-intercept is negative 2. So we'll graph that. And then my slope in front of the x is 2. So from that y-intercept, I'm going to graph up 2 and over 1. I'm going to even make another point. It's easier to get a straighter line. Up 2 over 1. So that I can, and it's important to draw your lines as straight as possible for this. Now, let's see if I can switch colors. I'm going to switch colors for my other line. Y equals negative half x plus 3. My y-intercept is plus 3. Negative 1/2 is my slope. Down 1 over 2. I'm going to do another down 1 over 2. And you can see my two lines intersect. Where do they intersect? Right there. That point is where they intersect. Now I need to tell what the solution is. The solution is going to be written as an ordered pair. Remember, an ordered pair is x and then y. So I'm going to write it as an ordered pair. So I find my x first, starting at the origin. That point is at 2, 2. So 2, 2 is my solution to that system of equations. So let's solve another one. Y equals negative 5x plus 3. Y equals negative x minus 1. Let's graph this first one. Plus 3 is my y-intercept. My slope is negative 5. Negative 5 is down 5 over 1. So 1, 2, 3, 4, 5. And then I've got to draw my line. I should get my meter stick out. That would be easier. Okay? negative x, that's the same as negative 1x, minus 1, so minus 1 is my y-intercept. And then my slope is negative 1, so down 1 over 1. And I'm going to do another one, down 1 over 1. I should have used the second color. But here we can see where that line intersects. It intersects right here. What's that coordinate pair as my solution? Do the x first, positive 1. So I'm going over 1, but down 2, negative 2. So the solution to both of those that is in common is 1, negative 2. Another example. So let's start with our y-intercept of negative 2. Graph our slope is up 1 over 3. Draw our line. I'm going to change colors this time, I'll remember. Graph our second equation, plus 3. Negative 4 over 3 is our slope, so down 4 over 3. Whoops. And our point of intersection, I was kind of off when I drew my line, is going to be right there. X is first, right? Our x is first, so we go over 3 and down 1. So, these are easy to graph. One thing we just need to keep in mind, we're graphing these because both of them are in slope-intercept form. When both of your equations are in slope-intercept form, it's really easy to graph them and get your solution to it. So that's what I've always done. Anytime I have both of them in slope-intercept form, I graph that system of equations, just like we're learning in this section. All right, one more example here. I'm going to show you what can happen and what the answer is if you run into a problem like this one. So let's graph the first one. Negative 3 is my y-intercept, so I graph it on the y-axis at negative 3. My slope is up 3, 1, 2, 3, over 2. So let's graph the next one. My y-intercept is 4. Okay. I go up 3 over 2. Well, I can't go up 3 over 2, but I can go back 3, or down 3, back 2, because that's going to be the same. Two negatives also make a positive. So 1, 2, 3, 1, 2. Sorry, that's not a straight line. But where do those lines intersect? They don't. They are parallel lines. How do I know that? Well, the slope, 3 over 2, 3 over 2, the slope is exactly the same, but they have different y-intercepts. Since the slope's the same and there's different y-intercept, that automatically tells me they're parallel lines, and parallel lines do not cross. So, what is the answer to this? There is no solution to this one, because they don't intersect. So if they are parallel lines, they do not intersect, and so there is no solution. All right, go ahead into Google Classroom. Make sure you check out the homework assignment that's with this video lesson. If you need more help, you can always rewatch the video. If not, reach out to me. We'll see you next time.